Hello and welcome. I'm going to do one more video on regex today. This is the third in a series, so I did one covering how to use regex test and the various different kind of building blocks of a pattern, one covering how to use regex extract and how to use it with dynamic arrays and some of the limitations of that, and today we're going to be talking about regex replace. So the basic idea is regex test says, does this string match this pattern? Regex extract says extract the piece of this string that matches this pattern, and regex replace says replace the piece of this string that matches this pattern with something else. So start off simple. This can be used for regular replacement. Think very much like the substitute function that already exists in Excel. So if you wanted to replace all the S's with K's, you could do that, and now it's not Sonuris, it's Conuris. But the nice thing with regex is that you can match more general patterns. So like this matches any digit. So we want to replace any digit with a star, no problem. We want to replace any digit this way with a star, no problem. We want to replace some range of digits, but not all of them with a star, no problem. So here we still have our 898, but all the rest are starred out. Here we want to replace any lowercase character with an underscore, and that's it. So the syntax is just regex replace the text, which is this column here, the pattern, which is this column here, and the replacement, which is this here. So that's kind of regular replacement. One of the more common applications you will probably use is removing special characters. So here, for example, if I want to remove, if you remember \w, so the lowercase w matches any uppercase letter, any lowercase letter, or any digit 0 to 9, and technically also an underscore, not sure why. And then the \uppercase w matches everything except that. So this is removing all special characters, but in this case including spaces. So you drop the parentheses, you drop the white space, you drop the dash. Similarly, you can use \s to just remove the white space, or you can use something like this, match everything that is not a letter or number or underscore or a white space. So that's either of those two. This negates it, so not that is the group, in which case you get rid of the parentheses and the dash. Or here you can match anything that is not a word or a space. And I just put this one in to sort of emphasize the difference between these two. This is a pretty common thing with data that you get from the internet. This looks like it has just a bunch of spaces between the end of the name and the start of the phone number, but actually some of them are ASCII 32 characters, which is a space, and some of them are ASCII 160 characters, which does not match space. So that's just kind of a reminder of why the \s to match white space characters is a little bit more general. Okay, so then in these we're just saying, replace everything with blank. You can also replace and trim. So here we're just going to replace everything with, here we've just got a space, even though you can't see anything there. So we're just going to replace with a space and then trim. So that means here, for example, where you've got a bunch of spaces and an open parentheses, those each get replaced with one space, and then the trim replaces the block of whatever 4 or 5 spaces with just one space. So here, if I'm interested in removing everything that's not a letter, then this is any letter, this is not that, all wrapped in a group. So I'm going to replace any non-letter with a space and then trim it. So all of this just becomes a block of spaces, and a block of spaces at the end gets removed. And likewise, I can replace here any \lowercase d is any digit, and \uppercase d is any non-digit. So I want to strip out any non-digit. But the key difference between sort of this version and this version, where you just replace it with nothing, is here, if I do that, I just get one big blob of numbers. But if I replace it with a space and then trim out my excess spaces, then I preserve the groups that the numbers appeared in when they're originally there. You can also achieve a lot of this stuff, like you can achieve this by doing regex extract to extract blocks of digits and then text joining them back together, but this also works just fine to replace everything else. Okay, so where regex replace starts getting more interesting is, first of all, you can use the match in the replacement. So in other words, here, if I say I want to find any uppercase character followed by some number of lowercase characters, and then I want to replace that. In the replacement, $0 stands for whatever you matched, and you can't see it, but there's a space after that. So I'm saying find a word defined as an uppercase character followed by some number of lowercase characters, and replace that with the same thing but with a space. So this is, not properly punctuated text. You can use this quite simply to split that up. I don't know why I still have the trim formula in here. That is, oh, sorry, I do know why I have it, because otherwise you'd get one extra space at the end, because it does match that last one as well. So that's like a nice simple way to split based on all kinds of transitions. So like here we're saying on a transition from a lowercase to an uppercase letter. You could also do it on transitions between letters and numbers, that kind of thing. Just lets you add punctuation. And you can basically add whatever you want around this. So you can say, I don't know, p : space 0 space dash, and you'll see that it sort of wraps that around each match. So that's one thing. The next thing that's even cooler is, oh, sorry, but before we get to even cooler, there's a weird behavior for no match. So with the substitute function, if I say substitute in here, the text SDF with RTY, it says, sure, I've replaced all instances of SDF with RTY. There were none, it doesn't matter. For some reason, and I think this is a bug, or at least I think this is not desirable behavior, but if you tell REGEXREPLACE to replace something that isn't there, so here it is with substitute, replace all the ones with blanks, no problem. With REGEXREPLACE, if this doesn't match anywhere, then it throws an error. I don't know why it would do that, as opposed to just saying it wasn't there, no problem. But anyway, for now, you can do a workaround with if error. So just say if error, REGEXREPLACE in this text, this pattern with this, and if it's not there, then just give me back the original text. I think it would be better if it didn't do that, but anyway, it is what it is. Okay, so now it gets more interesting, using capture groups in the replacement. So I talked about the idea of kind of replacing at a transition. Now here, strictly speaking, we were still looking for words, but this is literally doing a replacement at a transition. So we're saying find a lowercase character followed by an uppercase character with nothing in between. But now we've got two capture groups. So we're capturing that first one, and we're capturing the second one. So just like you use $0 to match the entire thing that you matched, you can use $1, $2, $3, $4 to match the first, second, third, fourth capture groups. So here we've got two capture groups. One is a lowercase letter, the other is an uppercase letter. And I want to replace that with $1, in other words, the first capture group, followed by a space, followed by $2, which is the second capture group. The nice thing about this one is, actually, I still have the trim there. I must have been a little lazy copying that down, but you don't need to keep the trim. So this will not match the lowercase o at the end or the uppercase m at the beginning. It'll only match a transition from lowercase to uppercase. So you don't have to worry about introducing extraneous spaces. And then well, I think that's cool already, but the even cooler thing is that you can then rearrange with capture groups. So here, for example, if you've got names in the form last name, comma, space, first name, or first and middle name or whatever, then you can match with a pattern like this. Say some number of letters and spaces is your first capture group, followed by a comma space, followed by some number of letters and spaces is your second capture group. But we're going to replace it with second capture group, followed by a space, followed by the first capture group. So then we get the names back in order, which is pretty cool. Okay, then the next section uses lookaheads and lookbacks, so we're going to go over to the next tab to talk about lookaheads and lookbacks. I will say, if you're new to regex and you just started watching over these videos, I never understand how YouTube works. The regex test video was like my most popular video ever, and then the regex extract video was just kind of average. I don't know if that's just because of the shock of the new, or because I put the other one out on a Friday, or because we were getting into slightly more advanced stuff and people are not as excited about advanced stuff. But like I said, if you're new to regex, if this is your first taste of it, then the look ahead and look behind might seem a little advanced and scary, especially because they use lots of symbols, which makes things seem complicated. If you want to stop here, that's totally fine. But I am going to explain what they do. It's not as scary as it might seem, and it's very kind of relatable to stuff we've covered earlier. but also I'm going to show you how in a lot of cases you don't need them. So the basic idea is if you want to match B, but only when it comes after A and before C, then you can just use this, A, B, C, and B can be whatever. B can be a phone number pattern, you know, D3 slash D4 dash, sorry, 43 again, dash slash D4, or it can be an email pattern, or it can be whatever, but you're saying you're only interested in matching it when it is preceded by this and followed by this, where, you know, any of A, B, and C can be some big complex regex pattern. So you can do this. You can do this with parentheses around B to capture only B. But if you want to replace B without touching A or C, then you'll need to use what's called a look ahead or a look behind. So basically, the syntax for them is a group, meaning parentheses, starting with a question mark, and then if it's looking ahead, it's just question mark equals. So in other words, what comes after? And if it's looking behind, it's question mark less than equals. So just think of it as, you know, an arrow pointing back. I don't know if my screen gets reoriented, but anyway, an arrow pointing that away. Versus here, just the equals pointing forward. I mean, in my head, it would be cleaner if it was that and that, but whatever, it isn't. So let's look at some examples. For regex test, and again, here I'm just using a literal ABC and a match of ABC, but this can be, you know, some more complicated thing, some more complicated thing, some more complicated thing, and this can be more complicated patterns. I just want to kind of keep it as simple as possible. So here, basically the answer is it makes no difference. So capture groups are generally not needed for regex test, and look ahead and look behind are generally not needed. I have to say generally, partly because when we looked at regex test, we did talk about one odd case where introducing a capture group, where is it here, lets you then reference that capture group later on. So that, you know, there are funky cases, but also just because regex is such a deep and complicated topic that I'm sure that if I ever make a statement as general as you don't need this in this context, somebody will find a counterexample. But for regular usage, if you just want to find, you know, is there a B in between an A and a C for regex test, you don't need either capture groups or look ahead and look behind. For regex extract, so if you just do regex extract of this text and this pattern, here it will pull out ABC, here it will pull out ABC, and here it will just pull out B. So in other words, these are a condition, but they're not part of the match. So it's, you know, it's matching a B if it's between an A and a C, but the A and the C are not part of the match. Here they are part of the match, but they're not part of the capture group, and so you can use the different return modes for regex extract. So here you're just saying extract by default, it gives you the first matching group, but you can also tell it give me the capture groups from the first match, and then it will just give you that B in the middle. But with regex replace, then it's different. So if I say regex replace ABC, here I'm just replacing them all with D. So if I say match the pattern ABC and replace with D, then the whole thing is gone. The A, the B, and the C are all replaced with D. If I say here, match ABC capturing B and replace with D, the whole thing is gone again. But here, if I say match this and replace it with D, well, the only bit that it actually matched is the B, and the A and the C are just conditions. So it's if there's an A behind and there's a C after, then match this B. But the A and the C are not part of the match. And so what that means is here you can replace only the B with a D and not have to touch the A or the C. You can also do this with capture groups. So here you can say, you know, capture what comes before, capture this thing, and capture what comes after, and then just replace it with the first capture group, followed by D replacing the second capture group, followed by the third capture group. So it's not that you can only do this with look aheads and look behinds, but you know, this here you can just say what you want to replace the thing with. Here you have to do a more complicated pattern. Then a sort of side note that look ahead and look behind can still be useful. So I said they're mainly, in my mind, for regex replace. There are simpler ways to do the same thing with regex test and regex extract. But here's a case where they can still be useful for regex extract. So just refer you back to where we were around the end of the regex extract video, which was extracting this kind of Senate voting data. And so we had this pattern that said, some number of characters, which is the name, followed by, a party code, followed by a state code, followed by, the bold tags with some text in the middle, followed by an end bold tag. And that is this pattern. And because of the way that regex extract works, you can either return all the matches, which will give you, the entire pattern for all whatever 5 different people that are here, or you can return the capture groups from the first match, so you get the name, the party, the state, and the vote, but just for the first person. But here, if we want to just capture one group from all the matches, then we can modify the syntax to a look ahead, look behind. And foolishly, I didn't prepare this one in advance, but hopefully that will serve to show that this is easy. So basically, let's say right now I'm interested in extracting the senators' names. So basically what I want to do is I want to change this bit that comes before it into a look behind, and this bit that comes after it into a look ahead. So a look behind, the syntax is open bracket, question mark, less than or equal to, then the thing that you want to match, which I just leave the same, and then close bracket. And then over here, I just want to match all the rest of this as a look ahead. So again, open parentheses, question mark equals, and then come all the way to the end and close parentheses. And now you can see the match is now not the whole pattern, it's just zooming in on this one piece of the pattern, which is the senator's name. And so I can pull out all 5 of those from here without having to do the sort of reduce or copy formula workarounds that I showed you before. So let's flip back over here. Now that we have look aheads and look behinds, let's show a couple of more interesting things we can do with REGEXREPLACE. So this is an example that I've seen used a few times for REGEXREPLACE as a way to do sanitizing of credit cards or phone numbers or other things. And this is an actual example that I saw somewhere, which is, take this credit card number, take this pattern, replace it with this bunch of stars, and you get this. Challenge is that if your credit card syntax changes a little bit, it doesn't work. If you're sanitizing a phone number and your phone number syntax changes a bit, it doesn't work. So with a look ahead and a look behind, here's an option to say, basically replace all the digits except the last 4 in a way that will work with absolutely any format, whether it's phone number, credit card, or anything. So you're saying, I want a digit followed by, and this is just, I don't know if we even need this question mark as a non-capturing group. I think, yeah, you can just leave that out. So sorry, I'm overcomplicating things. You can designate, so generally something contained in brackets would be a capture group. If you put question mark colon at the start of it, that designates it as a non-capturing group. But in this case, you don't need to worry about that. So let's not do that. So what we're interested in is a look ahead. So this is after this digit, there has to come some string of characters, a digit, and some string of characters 4 times. And remember, this some string of characters can be 0 or more. So this just means that, let's say I'm looking at this digit here, then after that there is a digit, a character and a digit, a digit. So there's 4 digits after that, so that one gets replaced. And that basically ends up replacing everything except the last 4 for any digit format. And then here I've got a slightly more complex pattern. So here I've got a mix of a phone number and an email. So here I'm doing a slightly crazy match. I'm matching either a digit that comes before at least 4 other digits, or I'm matching letters that come before an @ symbol. And that is a way of sanitizing both an email and a phone number. Now, if you had longer strings with multiple emails in them, then this is too simple. Believe it or not, if you're looking at this thinking it looks crazy complex, because these characters after this @ are still before this @. So you need to think about, maybe each set of emails is separated by line breaks, and you could use that as a delimiter, or maybe there's something else. But it can get more complicated. But anyway, here's a way to sanitize a phone number and an email address in the one cell, it can get more complicated. Then there's also, here's just some more advanced rearranging. So if you've got a bunch of text that looks like this, that contains an email address and a phone number, then you can use this pattern. So again, simple phone number matching pattern that we talked about before, 3 digits followed by a space or a dash, followed by 3 digits, followed by a space or a dash, followed by 4 digits, only matches US type phone numbers, whatever, lots of limitations on that we discussed before. And then here, a simple pattern for an email, which is, some letter and number characters followed by an at, followed by some letter and number characters, followed by a literal period, followed by some letter and number characters. And we're basically saying we want a look ahead that matches this and this. So in other words, sometime later these things come, and what we're actually matching is any number of characters. And what that means is we will replace all the characters, because this will match basically at the start of the string. You have a position where later there's an email and later there's a phone number, and you can match this entire thing. So you replace the whole string and you replace it with phone, colon, and the first capture group, email, colon, and the second capture group. So you'll notice that here the email comes first, the phone number comes later. Here the phone number comes first, the email comes later. They're all over the place. But if you apply this pattern, then you get a nice clean phone, email, phone, email, phone, email, phone, email. You can also do this same idea using regex extract. Here you've got one capture group, here you've got another capture group. And so you just say, give me all the capture groups and just split them out to a row, and you get phone, email, phone, email, phone, email, phone, email. Now I have to hop back over here because this was just my closing. This is the end of the regex intro. I may do some more videos later, just kind of digging deeper into some real life data that I started playing around with. But for now, if you're in what's probably the small sliver of people who've stuck around this far and still think you would like to delve further into the world of regex, then I recommend checking out rexegg.com. Presumably it's called rexegg because this person thinks of the term as regex, but I don't, as we've talked about before. But it is an amazing website. I came to it because I was watching Bo's video earlier where he mentioned greedy and lazy quantifiers, which I'd heard of, and possessive quantifiers, which I had not heard of. So I googled greedy, lazy, possessive quantifiers and came across this page on quantifiers, which explains the concept of quantifiers being greedy but docile, or lazy but helpful, or possessive, and just goes into an incredible amount of detail about, complex edge cases and how this relates to efficiency as you go through your browser. And this is just one page of, a dozen or more in the so-called black belt program. There's also a bunch of introductory stuff, and there's some fun humor, including the regex pattern that is the answer to life, the universe, and everything. So if you want to go deeper than I have gone, I recommend you check out rexegg. That's all I've got for today. Yeah, I don't know. I'm not sure what's coming next, but I'll be back before long. See you next time.